Hi, I Aziz welcome you to CoedMaster, and in this video we are going to solve this problem. The problem is given as we are given a number and we need to find the factorial of a number. So in case you do not know about factorial, the factorial is a multiplication of all the numbers from 1 to n. Let's understand this with an example. So let's say we have a number 5, and if we need to find the factorial of 5, then we simply have to do multiplication from 5 to 1. So it becomes 5 into 4 into 3 into 2 into 1. It comes out to be 120. If the number is 4, then we have to multiply 4 into 3 into 2 into 1, and it turns out to be 24. And by default, the factorial of 0 and 1 is 1. And here we are assuming that the value of n is greater than and equal to 0. So now you understood about what is factorial. Please pause this video and try to write a function that takes n as an input and return factorial of n. So let's first see the iterative solution of this problem. Right? We have a function factorial iterative, and this function takes n as input. It first initializes the result variable to 1, and simply it is running a loop from 2 to less than equal to n. And after loops gets completed, it simply returns result. So what we are trying to do here is, if n is equal to 1, we are simply running a loop from 2 to n. If n becomes 5, we are running loop from 2 to 5, and we are multiplying numbers in each iteration. For example, let's see with this example. So let's say we are passing n equal to 5 to this function, and the value of result is 1 by default. So in first iteration, our I becomes true. We are multiplying 1 with 2 and we get 2. In next iteration, when I becomes 3, we are simply multiplying 2 with 3 and we get 6. In next iteration, when I become 4, we simply multiplying 6 with 4 and we get 24. In next iteration, when I become 5, we simply multiplying 24 with 5 and we get 20. So this is how we simply multiplying numbers in each iteration. Let's say we have 5, so we are multiplying 5 into 4 into 3 into 2 into 1. And this is how we got our answer as 120. So the output of this function is going to be 120. Now let's talk about the time complexity of this function. So in this function, what we are doing basically, we are just simply running a loop from 2 to n. So it means we are running a loop n times. See, in asymptotic analysis, we generally do not care about the plus minus 1. So that's why I am considering that we are running a loop from 1 to n or n to 1. That's why the time complexity of this function is going to be theta of n. Now what about the space complexity of this function? You can clearly see that we are not using any extra array or something like that to store the values. We are simply using one variable, that is the result variable, and we need space only for the result variable. So it comes out to be a constant, right? So the space complexity of this function is going to be theta of 1, and that is constant. Now let's see the recursive solution of this problem. So this is a function factorial recursive, and this function takes n as input, and this function is simply making a recursive call to itself by reducing the input by 1. Now let's quickly dry run this function and see how it works. So let's say the value of n is 5 and we are passing 5 to this function. When we run this program, our function gets invoked. It simply do 5 into function of 4. It means it is making a recursive call to itself by reducing the n by 1. When this function gets called, the execution begins from the beginning, right? So what this function does, it simply do 4 into recursively call function with input 3. When this function gets executed, the execution begins again from the beginning. It simply do 3 into calling recursively a function by passing 2 as a parameter. Now when this function executes, it call for 2 into function by passing 1 as the input. When this function gets executed, it calls for 1 into function 0. So when the execution reaches here, we hit our base condition, and our base condition is when n equal to 0, return 1. So this recursive call hit the base condition and start returning. So function of 0 return 1 to its parent. Okay, so here this function call gets 1. It simply multiply by 2 and returns 2 to its parent. Now this function get 2 from its child. It multiplies into 3 and returns 6 to its parent. Now this function receives 6 from its child. It multiplies with 4 and returns 24 to its parent. And this function get 24 from its child. It simply multiplies with 5 and returns 120 to its parent. And this function simply returns 120 to our main function. So this is how this recursive call works. So, and the output of this function is going to be 120 because the factorial of 5 is 120. Now let's talk about the time complexity of this function. To determine the time complexity of this function, let's first write the recurrence relation of this function. So the time taken by this function is equal to time taken by the recursive function plus theta 1. Why theta 1? Because we are simply doing some constant operation here, multiplying and checking the condition. Now let's see how many levels we have in this recursive call. So if n is equal to 5, then we are going from n to 0. So from 0 to 5, it has 6 levels, right? So we can say that the number of levels in this recursive call is going to be n plus 1. So the time complexity of this recursive call is going to be theta of n. We ignore the constant here because we do not care about constant in asymptotic analysis. So we could say the time complexity of this recursive solution is theta of n. Now what about the space complexity? Now in previous example we were only using iteration. We didn't require any extra space for our iterative solution. But in recursive solution, all the function calls get stored in function call stack. And there is a moment in time when we reaches to function call with 0. At this moment, all these function calls are going to stay in our call stack. So we could say we need at least n amount of space to store all the function calls, right? So we could say this recursive solution takes n number of space to store the recursive function on a call stack. So the overall space complexity of this recursive function is going to be theta of n. So what is the best solution between iterative or recursive? If we consider the space complexity, then obviously the iterative solution is much better solution. And if we do not want to consider space complexity, then maybe recursive solution is better because it is easy to read and easy to implement. So I hope you got good understanding of both the solution, iterative as well as recursive. This is it for this video. Thanks for watching. See you in the next video.